could use the law of syllogism and, the law of detachment and the law of syllogism. Meaning, okay, so law of syllogism says this. I'm going to write this out just as a rule, okay? Well, actually, I'm going to use the if part. If P, then Q. Another way of saying that is P implies Q. When it implies it, it means that if you know P is true, then it suggests that it must be Q as well. Okay. You could have another conditional statement that says, if you know that Q is true, then you know that R is true. Okay. Or Q implies R. And kind of by, almost like some of you would say by the transitive property, it's a way of thinking about it. But really what you're saying is, if we know this is true, if we're told that P is true, we automatically know Q is true. And once you automatically know Q is true, this says, once you know Q is true, you know R is true. So if you know P is true, that leads you to here. That means that you know this is true, and that leads you to there. So the law of syllogism says you can then, if P then Q, and the next one, the conclusion of one is the hypothesis of the other, you can kind of take out the middleman and just say P leads you all the way through Q right to R. P implies R. Or if P, then R. Okay, that's the law of syllogism. Okay, and let me get all the green out of there and just write it in black. Okay, so that turns into if P, then R, or P implies R. Okay. Yep, so what's the next part of it? Well, that's the law of syllogism. The law of detachment says if you have any conditional statement, and this new one that you got through the law of syllogism, this one that you came up with, that's just a conditional statement. So if you know that is true, because you came up with it through a series of steps using law of syllogism, you now have this conditional statement. If you knew that P was true, you'd know that R was true. And then they say, now we're going to tell you a statement of fact. We're going to tell you P is true. Okay. Well, this says if P. Well, now we know, yeah, P. Yeah, we're in a situation where P is the case. Then we know that Q is the case. And if we know that Q is the case, which we do, then we know that R is the case. So what can you do when you have both law of detachment and law of syllogism together? Well, if it fits all the parameters that you have, an if P then Q statement and then an if Q then R statement, allowing you to come up with an if P then R statement, and then you're told, we know that the conditional of that new one through law of syllogism, we know that that conditional is the case. We're dealing with a situation where that's true. Okay, well then we must be dealing with a situation where that's true as well. Okay? That's the general idea of how you use law of detachment and law of syllogism together. So R is true. This will be the big payoff of all of that. Okay? So let's look up here. If a triangle has three angles with the same measure, then it is equiangular. This is the hypothesis. Hypothesis. If that, this is the conclusion, then that. Well, notice that the conclusion of that one, then it is equiangular, is the hypothesis of this one. If it's equiangular, and we now have then it's equilateral. So we can then jump straight through to say, if a triangle has three angles of the same measure, then it is equilateral. We've used this, we've used this law of detachment down here to say, now we have a new conditional statement. If the first part, if a triangle has three angles with the same measure, then we have this part down here, then it is equilateral. Okay? Now, the last thing we need to apply the law of detachment is to find out that the conditional in blue, this part, is actually the case. So then what do they tell you? Yeah, they say it's the case. Look, some triangle RST, does have three angles with the same measure. That's the condition we need to meet. If the triangle has three angles with the same measure, we can then say it's equiangular, and if we can say it's equiangular, then we can say it's equilateral. So if we know it has three angles with the same measure, and we do, therefore we can say triangle RST is equilateral. Triangle RST is equilateral. Yay! These two together are very powerful because they lead you from something earlier all the way through to something later. And then if you can say an early fact, the early fact being that the triangle has three angles of the same measure, then it leads you all the way through to this fact as well. And that's what we got. So love this problem. Love applying the law of detachment and law of syllogism together. And you've just got to be careful because the conclusion of one has to be the hypothesis of the other. And you will see some situations where it's not true, where they say, if a triangle has three angles of the same measure, then it is equiangular. And then it says again, if the triangle has three angles of the same measure, well, that's not giving you as a hypothesis what this one had as a conclusion. That would be the hypothesis is the same on both of them. Wouldn't matter. So you've got to make sure that the conclusion here is the hypothesis here, and then we can take this hypothesis together with this conclusion to have a new statement. And then, of course, the last bit is that you need to know that the hypothesis of that first part is true, leading you to the conclusion of the final thing.